Give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. We have f of x, which is equal to 2x squared plus 5 divided by x squared plus 4. So let's take a look here. So here is our rational function. We want to determine the vertical, the horizontal, and oblique asymptotes. Okay, so let's go ahead and take a look at the vertical asymptote. Again, a vertical asymptote occurs for every number that causes the denominator of the function to have a value of 0. So you should set the denominator equal to 0 to determine where vertical asymptotes will occur. Okay, so here we have x squared plus 4. Okay, when we take a look at this denominator, okay, the question we need to ask ourselves is, are there any values for x that when we plug it in for x, is it going to make this negative? Well, it's not, because when you square it, it's always going to be a positive number. So, for example, if we picked, let's say, -2, because we know that or -2 or +2, okay, if we put in -2, well, -2 squared is going to give us +4, and 4 plus 4 does not give us 0. So there's no option here, so therefore we do not have a vertical asymptote. So we're going to say no vertical asymptote. So let's go ahead and answer that question. So we would say that there is no vertical asymptote. Okay, now let's take a look at the definition for horizontal asymptotes. Now again, we finished part A here. Now let's take a look at B. It says, if the numerator has a lesser degree than the denominator, then there is a horizontal asymptote at y equals 0. Well, you can see here that this degree 2 here and this degree are the same, so we're not going to apply B. Now, if we take a look at C, it says if the numerator and denominator have the same degree, which they do, and the function is of the form, meaning that you're having a rational function here, then the horizontal asymptote is going to have the equation where y is equal to a over b, where a is the leading coefficient of the numerator, and you're going to divide that by the leading coefficient of the denominator, which would be b. So therefore, this would be 2 over 1. So y is going to equal 2 over 1, which is equal to 2. So therefore, the horizontal asymptote is y equals 2. Check your answer, and there is your result. Okay, and now if we just check to see now if there are any oblique asymptotes. Okay, now the definition of an oblique asymptote or the slanted asymptote is the following. Okay, it says here that if the numerator is of degree exactly 1 more than the denominator, well, we determined that it's the same, so it's not going to apply for that. So we don't have, so no oblique asymptote. So let's go ahead and then answer that question. So there is no oblique asymptote. Okay, now let's just verify this looking at the graph of what this rational function would look like. So in the numerator, we have 2x squared plus 5, and then we're dividing that by x squared plus 4. Okay, so let's take a look here. So you can see here that this graph continues. So there's no gaps in there. There's nothing that makes this undefined. So therefore, you're going to see that there isn't a vertical asymptote. Now, we do have a horizontal asymptote at y equals 2. So let's go ahead and take a look at that. So if you take a look here, here we have the point 0, 1.25. Okay, and then let's just plot the point 0, 2, so we know that where that point is on the y-axis. And there's that point, right? Now let's go ahead and then put in y equals 2, which is the horizontal asymptote. Well, you can see here that there is the horizontal asymptote, which means that this graph here is never going to go above that particular line. And therefore, that just confirms our result.